Dead Sea Scrolls should be part 10. Just to remind you, I have not read these. Modern Tech Meets Ancient Secrets. I've not read these, so when I'm seeing it the first time that you're hearing it. Radiocarbon dating and computer imaging allow scientists and scholars to date the Dead Sea Scrolls within margins of 300 years. There was a guy, it wasn't a Christian thing, it was a technology thing. And they're doing something for dating things by proteins. Something to do with proteins. And whereas we've always used, as I said, carbon dating and this other stuff, but they're finding out that somehow the way they look at certain proteins or something. And but the big point of it was that things aren't as old as they seem. The discovery of the first scrolls in 1947 dovetailed fortuitously with the development of radiocarbon dating, a method that could date carbon-containing organic objects. All but one of the Dead Sea Scrolls, the Copper Scroll, are made of parchment or papyrus, which are organic substances. There was one drawback to the process of radiocarbon dating the scrolls. A large piece of the material in question had to be destroyed in order to carbon date it. Understandably, no one wished to destroy a large portion of the historic find. Therefore, in 1950, 4 ounces of the linen scroll wrappers were sent for carbon dating. After testing, a date for the linen was placed between 167 and 233 CE. By the early 1990s, accelerator mass spectrometry, AMS, had been developed, a process that could carbon date using much less material and with greater accuracy than the earlier carbon-14 analysis. About 3 dozen scrolls taken from different caves were tested. AMS analysis suggested one of the scrolls likely dated from the 4th century BCE to the 3rd century CE. Most scholars accept the range of the Dead Sea Scrolls as between 200 BCE and 100 CE. This common thing, the C deal, drives me nuts. What was wrong with BC and E, or before Christ, after Christ? It's all very simple. Reconstructing a scroll. Researchers spent nearly 14 years sorting the estimated 15,000 scroll fragments from the caves and assembling them into different manuscripts. The fragments found lying in the dust of a cave floor or stuffed into the niches of the walls were assumed to belong to the scrolls in that cave. But which one? Workers determined which manuscript the fragments belonged to by the general color and condition of the papyrus, the paper, the handwriting, the columns and rulings, mean their style of writing, the ink, and the spelling. In many instances, they used the number of animal hairs per square centimeter on the leather to determine which fragments belonged near each other in the reconstruction process. At first, the original fragments were used in the reconstruction. Over time, however, the fragments deteriorated and the ink faded, making the writing difficult to read. Reconstructions are now done using photocopies taken from the original photographs shot by John Trevor in 1948. Well, at least they did that. Trevor's original negatives are in the collection of the Ancient Biblical Manuscript Center of the Claremont School of Theology in California. He died in 2006 at the age of 90. The Dead Sea Scrolls Digital Library. The Dead Sea Scrolls have been captured for posterity and are available to anyone with internet access. In partnership with Google Research and Development in Israel, the Israel Antiquities Authority has begun to document the entire Dead Sea Scrolls collection online. using the most advanced imaging and web technologies. The Leon Levy Dead Sea Scrolls Digital Library offers viewers high-resolution images of biblical texts such as Genesis and the Ten Commandments, as well as non-biblical and sectarian compositions. Showcasing the oldest known copies of Scripture to the entire world is made possible by cutting-edge spectral technology. This allows scientists to examine the images in the infrared range on the electromagnetic spectrum, allowing the murky or smudged letters to appear more clearly. The library plans to image and upload 10,000 fragments to the website. This will result in a kind of paradise for the public at large and for scholars, says Professor Emmanuel Tov of the Hebrew University in Jerusalem. All this freely on the internet. Truly a brave new world for all those interested in the Dead Sea Scrolls. This is a short one. We'll continue on. Imaging the scrolls. Photography has provided scholars an excellent record of the scrolls as they appeared after their discovery, even though the writing on many scrolls is no longer legible today. The diligent work of photographers since the discovery of the Dead Sea Scrolls has become increasingly indispensable as the manuscripts and fragments continue to deteriorate and darken. Many professional photographers have photographed portions of the scrolls, beginning with John Trevor immediately after their discovery. In 1949, photographer Helena Biberkraut photographed the temple scroll after her husband, James Biberkraut, a professor at Hebrew University, conducted the delicate, painstaking task of unfolding the multiple layers of aged, crinkled leather. Although the scroll had darkened to the point of near illegibility, Helena's use of infrared film helped reveal the content of the text. In 1952, Najib Albina of the Palestine Archaeological Museum began photographing the scrolls using infrared light on a large film format. In 2005-2006, the noted photographer of archaeological artifacts, Arden Bar Hama, made high-quality infrared digital photos of several fragments and columns, revealing physical deterioration of the pieces between Biberkraut's 1949 images and 2006. In the 1980s and 1990s, brothers Bruce and Kenneth Zuckerman of West Semitic Research in Palos Verdes, California, experimented with backlighting, which yielded improvements in color, infrared, and black and white formats. The technique used to create the remarkable scroll images featured in the Leon Levy Dead Sea Scrolls Digital Library employs a 39-megapixel computer-controlled camera system that takes photographs in the ultraviolet, infrared, and visible spectra. The Megavision system allows technicians to retrieve the faintest traces. I'm having trouble seeing this. There we go. The faintest traces of writing that have faded to illegibility over the millennia. The camera's sensors are revealing words never seen since the scrolls were hidden in the caves more than 2,000 years ago. That's interesting. Something new. The implications of such cutting-edge technology are enormous. Scholars will now be able to ramp up their study of the scrolls to previously unachievable heights. Equally important, the technology will allow for long-term monitoring for preservation purposes in a non-invasive and precise manner, according to the Levi Digital Library's website. The research continues. Since their discovery, the Dead Sea Scrolls have been subjected to nearly every imaging technique in use during the 20th and 21st centuries. Traditional color, black and white photography, ultraviolet and infrared photography, and visible light photography. But in 2010, fragments of the Temple Scroll were administered the most royal treatment to date. Researchers at the National Institute of Nuclear Physics in Catania, Sicily, bombarded the scroll fragments with alpha particles and X-rays, and then with proton beams produced by a particle accelerator. They nuked it. The researchers weren't interested in rendering the fragments more legible to read, but instead hoped to determine where the parchment was manufactured. Basically, we concentrated on water, physicist Giuseppe Pappalardo said. Like most of the other parchments, the Temple Scroll was made from animal skin. Thus, its production required extensive washing. Our goal was to compare and possibly find a match between the chemistry of the scroll and the very peculiar chemistry of the water from the area where the parchments were found. The testing revealed that the level of certain chemicals in the fragments was 3 times higher than is normally found in seawater. The testing revealed that the level of certain chemicals in the fragments was 3 times higher than is normally found in seawater. The research team concluded the parchment was probably made with the very salty water of the Dead Sea, suggesting it was made locally. And that's the end of part 10. Next is going to be preserving the scrolls. Love you, God bless.